Today we've got a couple of things on the agenda. First, we're going to discuss density and water displacement. Density and water displacement. And then finally, after that, we're going to talk about some physical and chemical changes. Density is an important and useful physical property. If you would look on your periodic table, the density is one of the things that it does tell you. I'm looking over here. Density is this little number, the bottom blue number. Okay, you can read right here, density. So you're going to need later on the density of gold. You're going to need that for a lab Monday. So right here it is, 19.3. What's the label? Grams per centimeter cubed. So density is one thing that your periodic table will tell you. Density is equal to the mass divided by the volume. This isn't any breakout stuff here, folks. You should probably have already dealt with density before. Mass over volume. Usually the labels we see are grams per cubic centimeter. Have we talked yet the fact that 1 cm cubed is equal to 1 ml? If we have not, you need to know that. A cubic centimeter is equal to a milliliter. Have you ever watched a TV show about, I just saw it the other day and I don't remember what show I was watching, but a nurse said, or maybe it was a doctor, said, give me 10 cc's. Okay? Those cc's are cubic centimeters, which would be equal to a milliliter. Huh? I don't know. I don't watch that, so probably not. Okay? I don't watch Grey's Anatomy. Never seen it. But nonetheless, that's important. 1 cubic centimeter is equal to 1 milliliter. Mercury, 13.6 grams per cubic centimeter is its density. Platinum, one of the more expensive of the metals, 21.5 grams per cubic centimeter. Aluminum, 2.7 grams per cubic centimeter is the density. So, right here, what I want you to do is I want you to answer this problem and calculate the density. Just a little bit of a help to walk you through this, people. Okay? How many folks caught this right here? How many people caught that? That we've got 3 measurements, 2 of them in centimeters, the third one is in millimeters. We need to pay attention to our labels. Because can we just do length times width times height with 3 different labels? Absolutely not. So we're going to have to convert that millimeters into centimeters also. Okay? So how are we going to do this problem? we're going to have to first get the dimensions into common units. So we need to convert those millimeters into centimeters. How do we do that? How do we go from milli to centi? We use a conversion chart of metric conversions. How many jumps is it? What direction? The other, right? One to the left. Okay? One to the left. We need to calculate the volume then in cubic centimeters. And then we can calculate the density. So those are the 3 steps that we need to follow. We need to get common units, everything in centimeters. We need to then do length times width times height to get my volume in cubic centimeters. And then we can use the mass divided by volume to get the density. So, as I'm going through, if I convert that, I jump 1 decimal place to the left to get me 0.095 centimeters. When I calculate the volume, 9.36 centimeters times 7.23 centimeters times 0.095 centimeters gives me 6.4 centimeters. Okay? Now, here's one point. Here's one point that I go by. This number right here, I'm assuming is rounded. When I do my rounding, I do not round until my final answer. So, as I'm looking, go ahead and multiply those 3 numbers together for me. Okay? As I'm looking at this, the number that we come up with is around 6.428916. I leave that entire number in my calculator because I'm going to end up dividing by the volume, right? So I divide by that entire number, not a rounded number. Because when you start dividing, you round, and then you round again, and then you round again, your number is going to be further and further and further off. So leave that entire number in your calculator, and then finally, calculate the density. Okay? Calculate the density. So we take the 57.54, divide it by the 6.4, whatever, and here's where I use the only 2 sig figs. Now, why are there only 2 sig figs? Why are there only 2 sig figs in this problem? Who can tell me that? Parker? We're doing multiplication and division, right? So we look at the smallest number of sig figs. And in this case, the 0.95 millimeters was our smallest amount, right? So that is why we have 2 significant digits. Here's another problem. Mercury has a density of 13.6 grams per cubic centimeter. What is the mass of 95 milliliters of mercury in grams? What is the mass in pounds? So, couple of things we have to do here. We have to manipulate our equation, right? We have to manipulate our equation because we have density and we have mass, and we are trying to solve for, check. We have density and we have volume, and we're trying to solve for mass. So, if we rework our equation, what would mass be equal to? What would mass be equal to? Try to picture that, John. Density times volume is equal to mass, just by reworking my equation. So, first thing that I need to remember is what I just put up on the board for you. 1 cubic centimeter is equal to 1 ml. 1 cubic centimeter is equal to 1 ml. So can I just look at this and just change that label to mLs? Yeah, they're equal. 1's equal to 1. We're okay with that. Change it if you want to. We need to use the volume to calculate the mass. Then we need to convert mass in grams to mass in pounds. We need to know a conversion factor. Where are we going to find that conversion factor at? Where are we going to find the mass to pounds conversion factor? Our agenda. Absolutely. We could look it up on the internet too. It's not a big deal. The conversion factor is 454 grams is equal to 1 pound. So, we convert the volume to the mass using the density. So now I have 1.3 times 10 to the third grams. I put that into scientific notation so that it's really equal to 1,300. Now I need to convert the mass in grams to mass in pounds. So I take the 1.3 times 10 to the third grams. What am I going to put on top? What am I going to put on the bottom of my conversion box? What am I going to put on the top and of the bottom of my conversion box? What do I want to cancel? Grams, right? So where will that go? Where? The bottom. Okay? So we're going to put that 454 grams on the bottom. 1 pound is going to be on the top. So when we do so, we get 2.8 pounds. Yes? Because that was asked in the question. Okay? The original question had 2 parts. It says converted to grams, and then how would that be? How much would that be in pounds? Okay? Now, go ahead and do this one. A little learning check for you. Calculate that out. First of all, before we even do any of our math, how many sig figs are we going to have? How many sig figs? Should be 3 sig figs. Because how many sig figs are in this 50 right here? 4. How many in 22.2 or 2.22? 3. We're doing division, so what's our smallest amount? 3. So we're going to have 3 sig figs. So what do you think? 1, 2, or 3? 1, 2, or 3? Number 2. Number 2 is the correct answer. 22.5 grams per cubic centimeter. There we go. Here we see how we actually solve the problem. The 50.00 divided by the 22.2. And notice our label right here, grams over cubic centimeters. Now you can see water displacement. It's also, I call it water displacement. The slide here says volume displacement. Okay? I guess you wouldn't have to use water. You could use some other liquid. But nonetheless, what we have done here in water displacement, we've taken a certain amount of water in our graduated cylinder. In this case, it's 25 milliliters. Then we added that block into the graduated cylinder and took another reading. Well, If the level of the water goes up to 33 milliliters, what must be the volume of that block? 8 milliliters, right? Now, that block looks like it's pretty much a rectangle, so we could probably have got that using length times width times mass. But when would we want to use water displacement? Rachel? If we had a ball, I mean, we could find the volume of a sphere, but yeah, if you had a ball, okay, Corey? If we had an irregular figure, what if I had a rock? Is a rock able to be measured? I mean, we could measure it, but our volume's not going to be very accurate. So if we have irregular objects, we can use water displacement to calculate the volume. To calculate the volume. You're going to be using water displacement coming up in our lab here. I think it's on Monday or Tuesday, yeah. What is the density in grams per cubic centimeter of 48 grams of a metal if the metal raises the water level in the graduated cylinder from 25 to 33? So we've got this little block. We just said it was 8 mLs, right? So how are we going to calculate that? We're going to take the 48. We're going to take the 48 grams, because we've got the mass of it. We're going to divide that by the 8 mLs. And it's going to give me what answer? Okay? It's going to give me number 2, which is 6 grams. Well, what's wrong with this whole thing? I can see a couple of errors on this. Number 1, it says meters cubed, right? Which is wrong. I'm going to have to go in here and switch this slide. Okay? I'm going to go switch this slide because it should be grams per centimeter cubed. That's one error. What else? Sig figs, right? How many sig figs am I dealing with? How many sig figs am I dealing with? 2, right? So what should my answer be? All right, let me ask you this, though. You're saying, okay, we subtracted 33, right? You know what? You're right. That is right, because we're doing addition and subtraction. So where should we be? At the ones, right? So that sig fig is correct. And let me show you why. Just to reiterate, I thought it was wrong. It would have been wrong if we were just doing division. 33/25. We subtract that and we get 8, right? Well, where's our uncertainty of these? Here and here. So where should my uncertainty be? Right there. So that 1 sig fig is correct. That's my bad. But definitely, that label needs adjusted. So I have to adjust that here. Now, another learning check, dealing with densities here. Which diagram represents the liquid layers in the cylinder? K is equal to Cairo. Syrup. Now, you guys can't see this very good, probably. So, that's a W. That's a K. The blue is K. That's a W. K, W. I think you can see the V's, but I'll fill in the V's here too. Now, based on the densities, Cairo syrup has a density of 1.4 grams per milliliter. Vegetable oil, the V, has a density of 0.91 grams per ml. and water is 1 gram per ml. So the question is, which diagram represents the correct liquid layer? How are we going to determine that? The what? We're going to use the densities, absolutely, but how? The most dense of these will be on the bottom. What is the most dense? Cairo. So it's got to be number 1, right? Because that's the only one where the Cairo syrup is on the bottom. Here's another learning check. Here's another learning check. The density of octane, a component of gasoline, is 0.702 grams per ml. What is the mass in kilograms of 875 mLs of octane? Go ahead and work that out. I'll give you a second to do that. Now, one thing I hope you recognize, ladies and gents, one thing I hope you recognize is that the question wants your answer in kilograms. You're going to get your answer in grams, and then you're going to have to convert grams to kilograms. So when I did this and multiplied it out, because mass is equal to density times volume, multiplied it out, and I got 614.25. Well, if you didn't follow or you didn't read it right, you're going to say right here, the 614. Incorrect, because 614's label is grams. I need to jump it 3 to the left to get it into kilograms. So the correct answer is number 1. Number 1. Another learning check, our last learning check here for the density, folks. If blood has a density of 1.05 grams per milliliter, how many liters of blood are donated if 575 grams of blood is given? Okay, go ahead and calculate that out, and then we will work that. Now, I know that D is equal to M over V. So when I'm solving for volume, volume is equal to what? Volume is equal to what? When I manipulate my equation. Okay, when I manipulate my equation, I need to multiply both sides by volume. So, mass is equal to density over volume. We just said that. So then we have to divide both sides by D. So, volume is mass divided by the density. When I take my mass and divide by the density, I get 547.619 blah, blah, blah. That's in milliliters, though. I need to then convert that to liters. Milliliters to liters is jumping 3 spots to the left-hand side. So my correct answer for this would be number 1, 0.548 liters. Okay,